The purpose of this experiment is to separate ethanol from a solution of distilled water and 190 proof ethanol using a batch distillation apparatus. This experiment can also be conducted using the fermentation broth from the fermentation experiment flasks. Distillation will be accomplished by boiling the solution and allowing the vapor to be processed through a column containing glass beads. As the vapor rises through the column, some of it condenses as a liquid and flows down by gravity to the bottom flask. The contact between rising vapor and downward flowing liquid has the effect of enriching the vapor in ethanol on its way up the column and enriching the downward flowing liquid in water. The ethanol containing vapor will then travel through a water-jacketed column, where it will condense and drip into a vial. As batch distillation proceeds, the liquid in the bottom flask becomes depleted in ethanol, and eventually nearly all ethanol will be separated and condensed from the top of the column. At the end of distillation, the vapor should be pure water. This procedure demonstrates the process of distillation. In actual biofuel production, the fermentation broth would be distilled to purify the ethanol that was produced. In this experiment, all samples of condensed vapors will be collected and measured for ethanol concentration. All collected ethanol should then be summed up and compared with the starting ethanol. This is called a mass balance, and our balance should be close to 100%. We will also take careful measurements of the distillation process, including temperatures of the liquid in the bottom flask and the vapor at the top, as well as volumes of ethanol product collected.
For this experiment, you will need the following pieces of equipment: safety goggles, rubber gloves, heat-resistant gloves, a lab notebook, a pencil, 8 20-milliliter vials, a 50-milliliter flat-bottom flask, a distillation kit, boiling chips, a hot plate, 2 digital thermometers, the 100 to 1000 microliter pipette, 1 milliliter plastic centrifuge tubes, and a scale. You will also need the following chemicals: distilled water and 95% ethanol. 70% ethanol by volume can also be used and can be purchased at a pharmacy like Walgreens or others.
Make sure to keep an organized lab notebook. Record all dates, procedures, and results. Wear safety glasses, long pants, and closed-toed shoes. Also wear gloves to avoid contact with chemicals. Ethanol is highly flammable and must be kept away from ignition sources. Be cautious with the pressure cooker and the hot plate to avoid burns and electrical shocks. Handle glass beakers with care to prevent breakage.
Using the scale, mass 8 separate vials. Label them with their mass and the numbers 1 through 8. It is very important that each vial remains with its own cap. To record your results, create a chart like this.
Using the 190 proof ethanol, which is 95% volume ethanol, and distilled water, create a solution that is 10% ethanol by mass. Your final solution will contain 40.02 milliliters of 95% ethanol and 268 milliliters of distilled water. These should be combined in a 500 milliliter flat-bottom flask. Adjust volumes accordingly if using 70% ethanol by volume.
Add 3 to 5 boiling chips to the flat-bottom flask.
Assemble the distillation kit as so, and remember to attach the segments together with the blue clips. Make sure to attach the tubing to the water-jacketed column and turn the water on so that the column is full.
To begin distillation, turn the heating plate to high power. Once the solution begins to boil, reduce the temperature slightly, but keep it high enough to allow vapor to pass all the way to the top of the column, where vapor will condense on the digital thermometer, and the thermometer reading will go up to the boiling point of ethanol.
Ensure that the solution continues to boil throughout distillation. Temperatures of both the boiling liquid and the condensing gas should be monitored at regular intervals, such as every 5 minutes. This information will help with assessing percent ethanol in the product. For reference, the boiling point of ethanol is 78.4 degrees Celsius, while the boiling point of water is 100 degrees Celsius.
At the beginning of distillation, the temperature of the vapor should be 70 to 80 degrees Celsius. The temperature of the top digital thermometer should gradually increase, and distillation should be stopped once it reaches 98 to 100 degrees Celsius. At this point, the vapor is almost entirely water because most of the ethanol has already been separated and collected. Vapor ethanol concentration can be estimated using temperature data and the vapor-liquid equilibrium curve. These estimates can be verified with density measurements, which will be done at the end of distillation.
Record the temperature of the top thermometer in your lab notebook every 5 minutes. Vapor will not reach the top of the condensing column for some time, and the hot plate setting may require some adjustment to ensure that the vapor begins condensing in the water-jacketed column and dripping into the vial.
The ethanol produced in the distillation should be collected in the 8 20 milliliter vials set up at the beginning of the experiment. Each of these vials should be allowed to fill up approximately to the halfway point, then removed, capped, set aside, and replaced. Make sure that the same caps remain with the same vials. This ensures that the mass of each vial itself, without the ethanol solution, is the same at the end of the experiment.
Turn off the hot plate and wait for the condensing column to cool to room temperature. During this time, a bucket should be put in place to collect the water that will continue to drip out. Once the condensing column has cooled, disassemble the distillation kit and pour the remaining 10% ethanol solution from the flat bottom flask down the drain. Wear heat-resistant gloves at this time, as the flat bottom flask may still be hot.
Complete the chart. This is done by first massing the full vials and determining the mass of the liquid by subtracting the empty vial mass from the full vial mass. Then, take 1 milliliter samples from each flask using the 100 to 1000 microliter pipette. Place the samples into plastic centrifuge tubes and mass them using the scale. Remember to mass the empty centrifuge tube first and then zero the scale so as not to include the mass of the container in your calculations. Use the masses to determine the density of the solution in each vial. This is done by taking the mass of the 1 milliliter solution and dividing it by 1 milliliter. Use the density to determine the concentration of ethanol in each vial using the ethanol density concentration table. Record all of this information in your chart. Once you have the percent ethanol in each vial, multiply this by the mass of the solution in each vial to determine the mass of ethanol in each vial. Add each mass together and divide this number by the initial mass of ethanol, which is 30 grams, and multiply by 100. This will give you your mass balance ethanol yield. Note that if the mass balance is less than 100%, some small amount of ethanol may still be in the flat bottom flask.
In Excel, graph the time versus temperature data that you collected with time on the x-axis and the temperature of the vapor at the top on the y-axis. Since boiling point is directly related to ethanol content, the graph will indicate the purity of the ethanol being collected over time. The purest ethanol would be collected at 78.4 degrees, and the purity would decrease as the temperature increases to around 100 degrees.